Hello.
Yeah, hello.
Good afternoon.
Good afternoon. So, good afternoon. Well, it seems that almost half of our students are here. Well, so this is the second part of your course in econometrics. Well, and I'm going to be your course instructor and lecturer in this term, as well as three my colleagues from management and economics department. Well, let me start the recording. Well, in accordance with our rules, we have to record lectures. Well, so what are we going to do today? Today we have to discuss our course plan for the spring term. So I should give you some organizational information. And next we should learn a new topic. So this topic isn't very large, but it could be very useful if you work on empirical term paper or you have plans to do an empirical bachelor thesis. Well, this topic is about panel data analysis. Well, what in general, what we have to learn in this course? In this course, we should cover two basic and large topics. First topic is about analysis of mainly microeconomic data or data when we observe different units or different objects over one period or over different periods of time. Well, and probably we will do all of this stuff in this model. And next, we should cover another interesting topic. This topic is about time series analysis. Time series analysis is a useful tool if you want to forecast or project demand for something or prices, price movements. Well, and for sure it is useful for finding relationships between different phenomena which we observe in time. Well, today I don't think that today we won't do something complicated and we won't do a lot of maths, but instead we should review your Econometrics 1 course. Especially we have to review linear regression, theory of linear regression, its assumptions, some maybe features of this regression. And next we should learn how to conduct a preliminary analysis when we work with panel data. But before doing all of this stuff, let me speak about our course. Our course is Econometrics 2, as you know, and well, course is pretty simple, I think. Well, let me share my screen. Yeah, well, so in this course we have two important points. So two important activities that we assess. So our final activity is exam. In exam you should present a small research project. Well, I asked you have to conduct a small econometric research. We will send you questions, research questions or tasks, and also we will send your data sets. Well, and you have to conduct a small and simple econometric research using methods you've learned in this course. Well, you should give a short presentation. It takes, as usual, from 10 to 15 minutes. It can be longer. Well, you should answer to all questions, and if your presentation is fine, if your calculations are fine, and if your answers are correct, you can pass. So definitely you can pass this exam. It is a teamwork, so we elect your instructors. We will make teams of students on the basis of your rating and other information. Well, so making teams, it's our duty, not yours. Well, and you have to work with your team to do research. So we will send you questions and data sets in the next module. I think it will be April. So you have probably 1.5 months to do an econometric research. Well, and all of you will have for sure the same time limit because, well, to do this research. Well, this is our final examination, and it has high weight. Weight of our exam is 0.7. Well, and another important activity is a seminar activity. Each seminar we IME instructors survey students as we did in statistics course, and we will assess your answers. You can earn maximum 1 point per seminar, minimum you can earn 0 point, and if your answer is partly correct, you could earn 0.5 points, likewise in statistics. But what is different now? Now we take into consideration your attendance. Well, if you miss more than half of our seminars, well, we will multiply your mark by the share of attended classes. So, for example, imagine a student who attended just one class. The student got 1 for this class. It looks good, but we see that share of its attended classes is 0.1. Hence, we multiply its 10 by 0.1, and his cumulative mark will be 1. Well, instead of 10. So please attend our classes and be ready for survey. Well, what questions can be in this course? In this course, we can ask you to interpret a regression model or regression model coefficients, or you have to solve a theoretical exercise in a class, or you should explain how to solve something or how this solution can be found. So using different properties from your probability theory course, from your linear algebra or calculus course, well, all of this stuff. It doesn't sound pretty hard, pretty difficult. Well, and what else? Again, so we take into consideration your attendance for seminars, lectures. We don't account your attendance for our lectures, but I strongly recommend you to attend lectures anyway, because as usual, we will consider some theoretical concepts and we will do exercises in Stata, and it is definitely easier to be in a lecture. So if you have any questions, well, so our main textbook is the same. It is Stock-Watson Introduction to Econometrics. Well, I recommend you to use the last edition of this textbook. Well, and recommended textbooks could be Virbeck, Marno Virbeck. It is a little bit more complicated textbook. Well, but if you are good in maths, and if you have pretty good knowledge of linear algebra, Virbac could be a fine companion. Another good textbook is Jeffrey Wooldridge's Introductory Econometrics course, a modern approach. Well, it is a little bit, it is very basic, but a little bit more technical than that of Stock-Watson's content. Well, and I think that's it. Well, and what we learned this course, first topic is panel data, next instrumental variable regressions, and so on. Well, that's all I think about organizational content. And I'm sure that you have questions. But I see that Ekaterina, you have a question. Yeah, please ask me your questions. Yeah.
Yeah, Evgeny, I have two questions. The first one, am I right that we wouldn't have any homeworks assessed like 0 or 1 in Stata as we did in the previous year?
No, this time no, because well, no, for sure we will give you homeworks, empirical homeworks with Stata, but and probably we will check it in our seminar as a part of our survey. But we know that all solutions for our main textbook are available in the internet, and it doesn't make sense to survey you a lot about your home tasks.
We wouldn't even have, like in the previous year, we had tasks from the textbook.
No, you will have a lot from your textbook, from other textbooks. You will have a lot of theoretical and empirical exercises.
Okay, and then the last question, I didn't really get the idea about the exam. Will it be in groups?
Yeah, it will be like your third year students, right?
Yeah.
No, it is similar to. No, I think that you know how to give, how to conduct a team presentation.
So we will, you will give us some time, like let's say 1 month, to prepare a project, to conduct all of the preliminary analysis needed, and then we will explain in public to you what was done, or you will ask us questions. Okay, then it's clear.
And let me stress, Ekaterina, thank you for your question. So sorry, I forgot to mention that in this course, likewise in statistics, we will pay a lot of attention to your soft skills, as your ability to explain what you have in the simplest manner. But if you want to get an excellent mark on your exam, you should be able to give the most clear and coherent presentation. And if your presentation is clear for the general audience, I mean the audience without background in statistics or econometrics, well, it will be perfect work. How many people will there be in a team? Is it possible to choose a team members, or will be assigned 4 or 5 persons in a team? And we will, I mean, instructors will assign students to the team. Well, okay, another question. I see Silvia.
Yes, I would like to ask about the exercise at the end of the third module. Do we have certain test, exam, or quiz for third module?
You mean midterm exam, something like that?
Yes.
No, in accordance with our program, we don't have it.
Okay, so we have only the exam at the end of the course, like a teamwork. Yes. Okay, thanks.
Yeah. No, finally, dear students, finally you have to show that you are able to estimate modal. In fact, using different sources, because you have 1 month to do it. It's an open book, in fact, examination. And you should show me that you are able to interpret your results and you understand what you did. Well, it is sufficient to pass the course. It's not very difficult. Well, you don't have to pay a lot of attention for technical details, but you can for sure, but it's not necessary. We would like to stress your understanding of ideas behind each model and interpretation. Елизавета. Елизавета, I see you have a question.
Do you hear me now?
Yeah.
Yeah, great. So I wanted to ask about those who are on mobility program. So we are studying online, and will we be able to go to seminars of others groups if there are some overlays in?
Well, yeah, that's a complicated question, because I think that our study office or dean should approve this. I never mind to see mobility students in this course. But there is one important organizational problem. What if you fail exam? Well, will it be DAPSA or will it be nothing for a student? Well, if you attend the course, and if you fail our exam, it should be DAPSA. No.
Yeah.
And I think only study office can explain this. If study office approves all of this stuff, I never mind. Please attend seminars. But you should also know that instructors, we cannot adjust our schedule with schedule of your university.
Yeah,
and
I'm
it
just
could be a problem.
Afraid that the attendance is graded, and sometimes it would be maybe impossible to mix.
Yeah, maybe because of this, it makes sense to take the same course next year. Well, but no, anyway, it's I think so. You should talk with study office, because look, no, attendance in principle in accordance with our rule, all students must attend classes regardless whether we count how many students attend our seminars. Well, and if you want to take this course now, so anyway, you should find time, maybe some time slots to attend all of our classes. Please discuss it with our study office. It's not a new problem, and I think they can easily find solution.
Yeah, thank you.
Yeah, Polina?
Yeah, hello. So there is a problem that some students studying econometrics 2, they are from fourth course for different reasons, for example, mobility programs, and so on. Yeah, and as I know, we should pass the exam and the whole econometrics 2 course before the fourth module will begin. So do you know what we should do in this case?
Well, yeah, that's also another complicated question. No, first of all, I think that, so I know that you have internship in the next module and you cannot take any courses.
Yeah.
It should be very strange to take any courses, or even probably it should be illegal. Well, and it seems that your exam should be in March when the third module is over, but you should ask our study office where your exam exactly will be. And your exam will be the same, likewise our summer exam, but if you are 4-year students, for sure you cannot take all topics from this course. No, you understand why, right? And hence you won't have to demonstrate knowledge of these topics in March. Well, but to be honest, your course will be pretty similar to the Econometrics 2 1 year ago. So because 1 year ago we didn't cover time series. But it must be in March, because I can't imagine how can you take an exam in June. It's strange. It could be strange.
Yeah, so we should write to study office or what?
Look, yeah, I think that it should be fine if you find someone like Starosta among 4-year students in econometrics, and if you write a collective email to our study office with the question where our exam should be, when our exam should be, and that's it. If you know where your exam will be, so you know what I will inform you what topics we can cover. And for me, it's also important because I have to send your tasks in advance, 1 month before the exam. Well, and no, please do it as soon as possible.
Yeah, okay. Thank you.
Yeah. Okay. Another question? Other questions? Will the exam be online or offline for those who are on mobility? No, well, I don't know, because my opinion, it's better to do. So for us, it doesn't matter for sure. For instructors, whether the exam is online or offline, because we can listen to your presentations online as well. But I think the format depends on the decision of our rector, and it depends also on the situation with coronavirus. I will be surprised if our exam will be offline. But right now, I don't know. And if you are on mobility, please also contact our study office. What should you do in this case? How teams for the exam will be formed? Instructors, as your lecturer and your seminar lecturers, will make these teams. We will take into account your rating, first of all. Students with highest ratings will be in one team. Students with low rating will be in another team together. They should do it together. And also we will take into account all the information about you. That's it about organizational issues.
And one more question. Can you hear me?
Yeah.
About econometric first marks, will we take it into account about our teams? No.
Econometrics first.
Yes, marks and seminars activity.
Yeah. No, not final marks only.
Final. So there was no situation like somebody with high marks will be in team with somebody with low marks. So it's like
not necessarily
unfair.
We will try to form students who have a good achievements in econometrics 1, a good rating will be in one team. No.
Okay,
so we don't want to mix students with different achievements. No, for sure, achievements anyway cannot be the same, but they cannot be too different.
Thank you.
And also our exam, I think, a good way for you to find new friends among other students. Okay, so now we have to discuss a new topic. This topic is about panel data research. But before panel data research, we should review basic concepts from linear regression models. Well, so you know that from statistics, I think you remember that I like to ask students about assumptions.
One more time, I'm sorry, but can you please send the presentation to the chat? Maybe it will be more useful.
Why?
No, because somebody make notes during presentation in the presentation.
Okay.
Thank you.
Well, you know that I like to ask students about questions about about assumptions and about consequences if we cannot hold these assumptions. Well, and what if we, and this course, or in this course also I'll ask you a lot about assumptions, about importance of different assumptions, and so on. Well, and you know that in linear regression model we have a lot of assumptions. Well, and today we have to review some assumptions from your textbook, but let me start with the very beginning. So you know that in econometrics 1, we try to estimate a linear regression Well, it looks like a linear equation, and you know that your regression, your dependent variable, it looks like a combination of observed variables and some unobserved error term. Well, and you know that this relationship must be linear in parameters, as x could be as x as is, or it could be logarithm of x, as well as y could be logarithmic value, or it could be row value. Well, so our job to estimate betas, well, and what does it mean estimate? So you know, likewise in statistics, we have a population and sample, right? And for example, when we conduct a survey, we collect some data. We cannot survey everyone, but instead we survey a small part of our population, and this part makes a sample data. Well, and we work with this sample data to estimate sample averages, sample standard deviations, or we run different statistical tests using on this sample data. Well, but what if you want, what if we want to estimate a linear regression model? Again, when we work with linear regression model, we work with sample data, and hence we cannot obtain population parameters, i.e. population betas. Instead, we estimate sample betas. All of our betas are estimated on the sample basis. Well, and this is the reason why we need to conduct different tests, t-tests, f-tests, confidence intervals in linear regression model. Well, you know what? Okay, we have to. I think so all of you know that we have to estimate this regression model, but what does it mean estimate? What does it mean estimation? Estimation means that first of all, we have to estimate betas. That straightforward idea. But what else? Betas are numbers. These numbers are random because we work with sample. And we need an indicator, we need something to measure how precise our estimated betas are. Not, for example, my beta 1 is 10, okay. Someone else can collect another sample and estimate the same regression model, and his beta 1 will be 12. Well, why 12? Because we use different we use the same population, but our samples are different. Well, and but how can we check whether our results indeed are the same, or maybe they are different? How to check whether our beta is a precise measure of the relationship between x and y? To do this, we should estimate, in addition to betas, we should estimate variances of betas, like variance in when we work with sample averages. But instead of standard deviations, now we calculate standard errors of beta, and standard errors of beta are our, so they show how precise our estimated intercept and slope coefficients are. Well, for sure, small standard, so if our standard errors are small, relatively to our betas, so it means that our estimations are pretty accurate. Well, and you know that if we can calculate variances of beta, we can calculate standard errors. Hence, we can run different hypothesis tests. As we can check whether our beta is different from 0. As we can run simple t-test, or we can calculate a confidence interval for beta to obtain interval estimate of the relationship between x and y. And also we can calculate different R-squareds, f-statistics, all of this stuff. Well, this is a pretty interesting part of any work, but what is interesting here, okay, we can for sure estimate betas, we can estimate the standard errors, but how can we know whether our betas tell us a true information? How can we check whether we can trust our results or whether we can obtain what we want to get from this regression? For example, I want to obtain a separate effect of one unit change in x1 on y. Well, I want to separate effect of x1 from other independent variables. For sure, I can estimate linear regression, but how can I check whether indeed my beta shows a relationship between x and y? Or how can I check whether I can trust results of my hypothesis tests? Well, and to check all of this stuff, well, to check whether we can trust our results requires some assumptions. So why we need assumptions in linear regression? In linear regression, we make assumptions to check, or we make these assumptions, well, to show that our results are trusted, to show that we can trust our results. Well, and you know that in linear regression we have many assumptions, much more than in simple t-test or in ANOVA. Well, and what these assumptions are? No, first assumption is simple. Well, it means that conditional expectation of our error term equals 0. One important note about assumptions, by the way, in econometrics. Please remember, in econometrics, usually we make assumptions about error term. Well, this is our maybe object of our interest. What is the problem with the error term? Why this term probably is the most important part in our regression? Because this term is unobserved. We cannot observe error term anyway. And this term, and once we cannot measure it, we cannot check whether we cannot use any statistical tools or econometric tools to check whether our assumptions are hold. And but we can use our argumentation, our experience, our intuition to check whether assumptions are hold. And this is the reason why our assumptions are purely theoretical concepts. They are very abstract things, but they are important because if we say that, okay, if we hold this assumption, this assumption, this assumption, and this assumption, we can trust these betas. Well, and a first assumption means that conditional expectation of error term equals on x equals 0, or our error term is independent on x. When this assumption is violated, for example, you have an observed phenomena, and this phenomena has a correlation with x. Example, we find a relationship between return of sales and investments in digitalization. Well, we want to answer a simple research question whether investing in digital technology could increase our firms' performance measured by return of sales. But also we know that return of sales or firm performance is an outcome of management quality. Okay, you can invest a lot of money in IT stuff, in IT technologies, but if your management style is bad, you will be bankrupt and your return of sales will be negative. Will be bad. But the problem is here is that we cannot measure appropriately management quality. For sure, there are some surveys, questionnaires to measure it, but there is no well-defined and clear method to measure management quality. Hence, it is an observed phenomena. And once it is unobserved, this phenomena, management quality will be inside the error term. But you know that management quality should be correlated with your independent variable. For example, if your management quality is high, probably you won't invest a lot, because as a good manager, you should economy your sources, you should save your resources. And probably your investments in IT, in digital technologies won't be large compared to companies with bad management. And probably your staff or probably your labor productivity, which is also important control variable, could be high if you have good management quality, meaning that this variable will be correlated with epsilon. Well, but we assume that but we assume anyway that our error term is uncorrelated with x, so its conditional expectation on x is 0. Well, that's good, but it's not very realistic. Another important assumption that x and y are independently and identically distributed. What does it mean? It means that our sample, robustly speaking, our sample is representative. There is no selection problem in our sample. Well, and so this is a pretty common problem if you work with survey data, especially if you note, for example, you analyze firm performance using Russian data, and you know that if you have IP or sole proprietorship, you cannot observe financial indicators of sole proprietorships in Russia. You can observe financial indicators of legal entities only, like or in Russia. But in this case, your sample, if you collect such a data, your sample cannot be representative, because many small firms prefer self-employment status or sole proprietorship status instead of legal entity, and so this assumption can be violated. Another important assumption, but is about outliers. Large outliers are unlikely, and other well, one comment about assumption 1. We use assumption 1 to obtain unbiased and consistent betas. Well, this assumption gives us good betas, as our betas are unbiased and consistent. Well, another assumption, assumption 4, means that our error term conditional on x has the same variance. It means that our error term is independent, our variance of our error term is independent on x, which means that our error terms are homogeneous. Well, this assumption is important to obtain standard errors, to obtain reliable standard errors. If this assumption is violated, we cannot trust our usual standard errors, and instead we should calculate robust standard errors. Well, and another important assumption, there is no perfect multicollinearity. Well, if you have a perfect multicollinearity problem, you cannot estimate your regression, as you cannot obtain your regression parameters well, and usually statistical packages automatically fix a problem of perfect multicollinearity. Well, if we hold all of these assumptions, our betas will be blue, as they will be best linear conditionally unbiased estimators. In addition to this, but for sure in practice, it is impossible to hold all of this assumption, and it is very difficult to get blue betas. But what is maybe necessary for us, and what probably is the most important assumption, is assumption 1, meaning that our error term, that expectation of error term on x is 0, or robustly speaking, our error term is independent on x. In this case, if this assumption is held, our betas will be consistent. What does it mean, consistency? It means that it makes sense to invest in data collection. It means that if you collect more data, your beta will be more accurate, as well as your standard errors will be more accurate. Well, and there is another important assumption, assumption 6, meaning that error term follows a normal distribution with 0 expectation and constant variance. well, why do we need this assumption? If this assumption is held, hence our betas follows the normal distribution, hence we can apply t-test and estimate confidence intervals, and moreover we can trust our t-test and confidence intervals in the regression model. Well, again, these assumptions are theoretical and very abstract, and we cannot check them using statistical tools. Well, if we imply that these assumptions are held, we can easily estimate OLS. We can easily estimate linear regression using OLS method, and we can trust our results. Well, but for sure, in practice, usually we cannot violate. Usually we violate assumption number 4. In this case, we estimate robust standard errors. And what else? But so violation of this assumption is not a serious problem. But what is a problem when our when our error term is correlated with X. If we have such a correlation, we have a bias in our estimated betas. Our estimated betas will be different from true betas if we collect more data. Hence, our estimated betas cannot be consistent. Well, especially if the omitted variable is statistically significant, it could be statistically significant, and if our omitted variable is correlated with the observed variable X. If there is no correlation, so it's not a problem. Well, and it is a pretty common problem in econometrics. Well, because usually we always, when we work especially with cross-sectional data, we always unobserve something. We cannot observe management quality, we cannot observe psychological atmosphere in a company, we cannot observe conflicts in companies. But what else, even if you find a survey, a brilliant survey which measures all of this stuff, probably there are other determinants, other unobserved determinants which are unknown for us. You know that management is a science, and probably there are other factors, phenomena which are unknown for us, but they are very important for management, for firm performance, and they are correlated with financial indicators, firm size, and so on. And all of this stuff will be in error. All of these phenomena and observed phenomena will be in our error terms, leading to omitted variable bias problem. And what can we? And also, you know that omitted variable problem, it is one of the most probably popular sources of endogeneity in your regression outputs. Hence, if you have endogeneity, you cannot speak about causal relationships between X and Y. What can we do to solve omitted variable problem? Or in principle, can we solve such a problem? I would say that it's a pretty difficult to solve this problem, but sometimes it could be partly solved. And what can we do to partly solve such a omitted variable bias, solve such a problem? We can use panel data. Well, panel data is a brilliant method to solve a problem when we have an observed characteristics. Another method, which we will learn in this course, it is an instrumental variable regression. It is a pretty good method, especially if you have a simple cross-sectional data. What else? We can use experiments, experimental data. Experiments are pretty popular now, especially among marketing analysts. For example, you want to check whether does it make sense to maybe to offer discount cards maybe to offer some discount programs to your customers. Well, you don't know whether it could work for your sales, for your firm performance, or you can conduct a simple experiment and to check whether it works. For sure, all of these methods can be used in practice, but sometimes they cannot be used because and it's not very easy to use them in practice because they have certain disadvantages and certain limitations. Well, and we should in this course discuss what these disadvantages and limitations are. No, you will understand it, I think, it easily. Well, and we cannot always solve the omitted variable problem, in fact, but sometimes we can. And final strategy to work with omitted variable problems: do nothing. And to be honest, it is the most popular way to solve the omitted variable problem. Just forget about it. Well, personally, recently I published a paper and I had omitted variable problem. I didn't have data to solve it. So I didn't have panel data. I couldn't apply instrumental variable regressions. I couldn't run experiments. So I decided to do nothing with that. But anyway, so these results could be pretty interesting and useful for practice. But interpretation of such regressions could be done with some caution. Well, what else? So, panel data. So the simplest probably probably the simplest way to solve the omitted variable problem is to rely on panel data. But first of all, what does it mean, panel data? Panel data is a data set. It is a spreadsheet, likewise a table in Excel. But now we observe the same units more than one time. For example, I can survey the same households 2 or 3 years. I have 100 households, families, and I survey each family 3 times annually. Well, if I collect my survey results, well, I will get a panel data. Another example of panel data is the annual macroeconomic statistics in OECD countries. For example, I can collect information about GDP, unemployment, consumer price index among OECD countries from 2000 year to 2012 year. Well, in this case, I observe the same country over time, hence I work with panel data. Another example of panel data could be about firms. We can collect financial indicators among the same firms over 10 years. And in this case, we will have panel data again. In total, any panel data set has 2 dimensions. It has individual dimension. Individual dimension shows us how many units of firms or individuals we have, and time dimension, how many periods we observe our individuals. Well, and note that cross-sectional data has 1 dimension only, so only individual dimension. And from this definition, you should note that if you want to solve omitted variable problem using panel data, first of all, you should collect such data. And sometimes it could be pretty easy. For example, if you sell something on Wildberries or Ozon, you can web scrape data every month. So data about shops, about products, about prices of products to get a panel. But often we cannot obtain panel data, or it could be pretty difficult to survey the same individuals or the same firms every year. Well, and this is the reason why often we cannot apply panel data methods in practice. So if you want to apply it, first of all, collect panel data, and it's not so easy. Next, why panel data? No, first of all, panel data, yeah, it could solve a method variable problem, but moreover, it can give us more interesting information about the phenomena studied. Well, first of all, we can identify changes over time at the individual level, not aggregate level. Next, we can correct for time invariant and observable effects correlated with observable independent variables, as we can solve omitted variable problems. And finally, we can obtain more efficient estimates because we observe the same individual several times. What does it mean? More efficient estimates. Our estimates, our betas could be more accurate if we work with panel data than that of cross-sectional data. No, for sure, there are some disadvantages, well, but we will speak about them later, not today. What should you do when you work with panel data? First of all, you should run a preliminary analysis. What should you do first? Sometimes you have to reshape dataset. You should create a panel. We will speak about reshaping dataset not today. I think that today we don't have, no, we have time. Today, next, once you reshape your dataset, you should declare status that the dataset is a panel data. State doesn't understand whether you work with cross-sectional or panel data. You should tell state that your data is a panel. You should, to do this, use xtset command. Next, you should describe the participation pattern, xtdescribe command, and you should calculate panel summary statistics using xtsum command in Stata. Well, before using these commands in practice, let me explain, let me give you 4 important definitions. Well, first you should distinguish between balanced panel and unbalanced panel. But a panel is balanced when we observe each subject the same number of periods. But if I survey all students from management every week, I will get a balanced panel. There is also an unbalanced panel. A panel is unbalanced when each entity has a different number of observations. For example, if I survey all of you today, and if I survey all of you next week, I could obtain an unbalanced panel if someone will be on a sick leave. For example, 10 students will be on a sick leave next week. Hence, they passed survey today, but they won't pass survey next week. In this case, not all persons are observed the same number of periods. In this case, we'll have unbalanced panel. In practice, when we work with country data, when we work with regional data, it's pretty easy to obtain balanced panel. But if you work with survey data or firm level data, usually you will work with unbalanced panels. In your textbook, or I think that in all undergraduate level and basic textbooks in econometrics, we imply that our panel is balanced, and we don't discuss how theoretical issues related to the estimation of an unbalanced panel. So theory of unbalanced panel estimation is for advanced econometric courses or intermediate econometrics at least. Well, but anyway, we will work with unbalanced panel too, but we will skip all maybe theoretical issues. Next you should distinguish between short panel and long panel. What's the difference? Short panel is a panel when there are more cross-sectional subjects than the time periods. In management, usually we work with short panels, to be honest, because we work with surveys, survey of our clients, survey of firms, survey of households, and well, but if you work with macroeconomic statistics, you will work probably with a long panel. Long panel is a case when number of period is greater than the number of units. Or for example, if you collect data on OECD countries from 60s up to now, you will obtain a long panel. especially if your data will be quarterly. Well, and today we have to learn how to distinguish, how to check whether our panel is balanced or unbalanced in Stata, whether our panel is short or long in Stata, and something else. Please, now everyone, could you please, I sent you a data set.
Sandrich, may I ask you a question regarding the previous slide where we had the commons, Stata commons? Could you please clarify what does it mean, their participation pattern?
Yeah, I want to do it right now in Stata. It's better to show it in Stata. Now everyone, I send you zip archive user RLMS HUC in dataset. Please unzip this data and open it in Stata. If you want to follow me or just look what I do in Stata. Oh, not this one, not this one. Please don't open this data. It could be too maybe too difficult for you to open it. Maybe it's better to open this one. Wait. Panel data lecture dataset, please download and open it in Stata. Let me.
Is it the same that you sent in the zip file? Because I already managed to open it.
Dataset is the same, but panel data lecture has less variables and it is easier to proceed it.
I see.
If your computer memory is small, it could be difficult to work with user RLMS dataset. Please type plus if you are ready for Stata. Okay, well, here and in Stata, we work with the panel data. Panel data, first of all, how it looks like. Let me share my screen. Now, type browse. And look what we have when we work with the panel data. When we work with panel data, we always have two variables. So first variable is ID variable or ID IND variable or variable measuring units or unique ID or ID. This variable shows unique numbers for each person or for each firm.
Excuse me.
Yeah.
I can't see your screen.
Me too. We have only white board without anything.
Oh. Okay, let's do view. And now? Do you see my Stata?
No, black screen.
Oh, well, that's a probably problem with connection. Wait, and now do you hear me? Do you see me?
We hear you, but we don't see.
Wait, and now?
No, the same thing.
Still, yes.
Yeah, that's a problem. Sorry, with an internet connection. Okay, well, let's do. Okay. Let's wait a little. I'm going to send you comments to our chat. And you should do this. Please first type browse in your Stata. Successful?
Yeah.
Well, look, you have a spreadsheet with Dated, likewise a spreadsheet with Excel. And could you please find a column ID IND? Well, I think you have it. And first numbers are 1, 2, 3, 4, 5, 6, and so on. This column shows us the individual level dimension. This column shows unique numbers for each person surveyed. It is likewise your passport numbers. Well, and another column is year. You see that first year is 1994. If you scroll down, please scroll down as many as you can, you will see that the last year is 2019 and the last number ID IND is 59413. Do you have it?
Yes.
Yeah. Okay. Well, next. This data is in a long form. What does it mean? It means that both year and ID IND are columns. Well, what if we have to get data in a wide form? Let's do this exercise. Do you see? Oh, no, you cannot see. There is something strange with Teams. Okay, now please let's try to use reshape command in Stata. Before using reshape command, please keep. Let me give you. Please do this command in Stata. Yeah, let me try to leave and enter the conversation again. There is problem with Teams. Do you see me? Do you hear me?
Hello, yes.
Oh, fine, yeah, last 10 minutes. Okay, don't repeat the same comments. Let me show everything.
We can see screen.
Can see? Great.
We can.
Yes. Well, first, what's the difference between let's keep class variables. Well, there is a comment in state reshape. Now this data is in a long term. Let me show you the difference. Well, sometimes we need to reshape our comments. For example, there is a wide form of our data set, and let's reshape all of our variables using D and your weight. Our shape wide. Yeah. Yeah, now that works. Well, let me show you. Look, what's the difference between long and wide? If you have long data, well, in panel data, we have two dimensions, as I mentioned. First dimension, it is I. Second dimension, it is yod. Yod usually is 0. I usually it is individual level dimension. It is a long form of data. If we speak about wide form of data, we have just one dimension. It is individual level dimension. But every column, but we have more columns, and each column shows so for example, there is a variable education, and we will have a lot of education columns, education for 1994, education for 1995, and so on. Let me try to well, let me show you. Now this data is in a wide form. Look. Not now. Let's use this one. Look, what I have the same ID IND variable. I have the same almost 60 persons, but now I observe education of each person many times, and one column is for 1 euro. Well, if you have such a data, you cannot analyze it as a panel data. You should transform it to long form. To transform it to long form, you should use reshape long education, and so options must be the same. Look. But now this data is in a long form. What's the difference? We have two columns, and we observe the same individual. Look, ID IND is the same from 1994 to 2019, and we have some information for this person. It is the first important step is in our analysis. Well, when you work with panel data, check whether your data is in a long form. And in this seminar, in the next seminar, we will check whether you can distinguish between long form and wide form. Next, you should tell status that your data set is a panel data. It is pretty simple. You should use xdset command. Next, you should type your variable measuring individual level dimension, ID, IND, and personal level dimension, euro. That's it. And look, output of this command is also pretty interesting. First of all, it says what is our individual level variable. It is ID, IND, and here it tells whether our panel is balanced or unbalanced. Look, data shows that our panel is unbalanced, and it is a way how to distinguish, how to check whether our panel is unbalanced or balanced. Next, it shows a time dimension and whether there are some gaps. We have gaps. And what is delta? Well, next you should use xtdescribe command. Well, it is about participation patterns. Note we have 5 minutes and it will be sufficient to explain it. Look, what we have. Here we have, it is a simple descriptive statistics for our panel dataset. ID shows how many units we have, almost 60. Well, year shows how many periods we have. Span, it shows that we have 26 years. Well, it is delta, likewise in XTSAT, and we have distribution. What else? Distribution and these two interesting indicators. Well, we see that distribution of T, it is distribution of time. For example, we see that maximum number of periods we observe the same person is 24. Minimum number of periods we observe the same person is 1. And in this table, we can count how many persons. But in total, we have almost 60 persons, and we can count how many persons we observe in the first period only. In 1994, we observe just 3% of our sample. And we also can find this row. This row shows that we observe 1,198 persons, or 2% of our samples, almost all periods in our data sets. In fact, it is all periods because there are 2 gaps. Well, look, while in our data we have almost 60,000 persons, just 2% of them are observed from 1994 years. And we see that nearly 2.4% of persons are observed probably from 2002 to 2003 years. Well, this information is pretty important because it shows for example, you want to analyze data on the same individuals from 2000 year to 2019. In this case, you should use if operator, and you will see that, okay, but I want to analyze persons from 2000 year. My sample in this case will be nearly 2000. Will consist of 2,000 respondents. It's a pretty small sample, by the way. What does it mean for us? It means that, so when we have such a small sample, probably our analysis can be very precise on one hand. On the other hand, we can get some selection problems. Probably our tests can be very powerful. Well, it could be a problem. For sure, if we observe a short panel, for example, if our panel starts from 2017, look, now 70% of our sample of 15,000 respondents could be covered by our analysis. So if I analyze the same persons from 2017 up to this period, I can cover 50,000 persons. What does it mean? It means that usually when we work with real data, it's pretty difficult to observe the same persons over a long period of time. But it is pretty easy to observe the same persons when we work with short periods, 2, 3 years, 5 years. And well, at home, I will send you some reading, some manual how to read this table, Please learn it And in seminar we will check how to interpret all of this stuff. Well, what options we have here? We have an option pattern. For example, I can obtain 20 patterns. Well, not maybe. Yeah. Look, if I set patterns 20, Stata will show me more rows in this table. One row is one pattern. Look, this is the first pattern, and it is the most popular pattern. It shows that 2007 persons observed from 2000 year and up to this period. We see that this number of persons are observed probably from 2010 years. Well, and we see, look, if you look at this pattern, we see that most of our people in this data set are observed from 2010 years. Well, hence probably it's better to analyze a shorter panel if you want to cover more people. Well, that's it. At home, you will have to be able to distinguish. So at home, please learn how to reshape dataset, how to work with XTDescribe, how to check whether your panel is balanced or unbalanced. And please also review your lecture notes from Econometrics 1 about linear regression analysis. In the next seminar, next seminar, we will check also whether you can interpret coefficients in simple and multivariable linear regression. Please be able to interpret log linear models, log models, and be able to interpret some interaction terms. Well, so in this course, you have to be very good in interpretation. That's it. Well, sorry for technical problems. So if you have any questions, so you can ask.
Could you please send the comments you used?
Yeah, for sure. Not for sure. Anna, yeah.
Is there a group which studies online? I mean, seminars. Is it like 198 group, right?
Yeah.
Or
yeah. Yeah, 7 or 8. I won't be a seminar instructor in this group. Well, yeah, this group exists for sure.
198.
There is a problem because our study office didn't sell me list of students. Now, probably yes.
Okay, thank you.
Evgeny Alexandrovich, so you mentioned that the students will be grouped according to the rating. Do you mean the rating for the econometrics course or the whole rating we have?
Both information pieces. No, and rating and econometrics, because we need to take into account your econometrics marks, because this course is very different from theoretical courses in your program. Someone could be very good in organizational science strategy, but could be not so good in econometrics, and vice versa for sure could be possible. And this is the reason that we have to combine both pieces of information. Other questions?
Yes, sorry. I wanted to ask, from this semester, I'm an online group